Hi girls, this is example 7. Two cars capital A and B are traveling with velocities u and v towards O along two perpendicular roads xo and yo, that is horizontal and vertical axis. Initially they are at x and y, and xo is small a and yo is b. Show that they will be nearest to each other after a time au plus bv by u squared plus v squared. In the first figure, xc and xc and yd are the velocities of a and b. So the velocities given are u and v respectively. If angle OXY in your first diagram is alpha, then cos alpha is equal to OX by XY, which is equal to OX is A, small a given, and XY is root of A square plus B square. This XY root of A square plus B square we are getting by Pythagoras theorem. Hypotenuse square is equal to sum of squares of the other two sides. That is, hypotenuse is equal to root of A square plus B square. So cos alpha is equal to A by root of A square plus B square, and sin alpha is equal to OY by XY, which is equal to B by root of A square plus B square. Take this as equation number 1. In the second figure, xd dash is the reversed velocity of B. We are bringing both the velocities in a single point. Already we have u in the horizontal direction and v in the vertically upward direction. But in the same point we are bringing the second velocity v. So we have to take the reversed velocity. So it is acting vertically downwards in the direction xd dash. And xp is the velocity of A relative to B, that is, see the parallelogram cx d dash p, and the relative velocity is nothing but the resultant. The resultant is nothing but it's the diagonal of the parallelogram cx d dash p, so it is represented by xp. And already you know the resultant formula as root of v1 square plus v2 square. Therefore, it is equal to root of u square plus v square. The line xpq is the path of A in its motion relative to B. If n is the foot of the perpendicular drawn from y to xq, n is the foot of the perpendicular drawn from y to xq. Ny is the minimum distance between the cars A and B. If theta is the angle nxy, then the time t taken by A to move from x to n in its relative motion, time is equal to distance by speed. So xn by speed, which is equal to xn. For that we have to consider the right angle triangle yxn, and in that we have to calculate cos theta. Cos theta is equal to xy by xn. Therefore xn is equal to cos theta into xy. So xy cos theta by speed already we calculated as root of u square plus v square. That has to be substituted here. So xy cos theta by root of u square plus v square, and xy already we got as root of a square plus b square. So finally what we are having is root of a square plus b square into cos theta. This theta we are representing as angle PXC minus alpha. PXC, the whole thing, minus angle OAB, that is alpha. Therefore, theta is equal to angle PXC minus alpha. But we have cos of PXC is equal to you see the right angle triangle OXY. In that, the hypotenuse is XY. So we are going to calculate what is cos of CXY and sin of CXY. Sorry, not CXY, it's PXC cos of PXC is equal to adjacent side, that is u by root of u square plus v square, and sin of PXC is equal to opposite side, that is v by root of u square plus v square. That is equation number 2. Now capital T is equal to root of u square plus v square into cos of PXC minus alpha by root of u square plus v square. Cos of PXC minus alpha has to be expanded using the formula cos A minus B. Cos A minus B is equal to cos A cos B plus sin A sin B. So using the formula, we have to first expand it and we have to substitute all the values. Simplifying that, finally we are getting this equation. Capital T is equal to AU plus BV plus by U square plus V square.